Hello everyone and welcome back to question 5 on this OCR A-level maths paper. Now we really are ramping things up. This is a difficult question. But if you know your principles of parametric functions and trigonometry, should be absolutely superb. So let's give it a go. So what you need to know for this is that when you are integrating parametrics, we have a formula. So the formula is y dx by dt. Okay, and what's quite nice about this is, although we can't treat derivatives as fractions, the dt's kind of cancel out, and this is equivalent to y dx, which we know allows us to find areas under curves. So, what do we know? We know y, we don't know dx by dt, but we know x, and in the question, it's quite a nice question, it's about an emblem for a maths department, but we're told that this curve is between 0 and pi. In other words, this here is pi, and we want the area to be 1 meter squared. So the first part is a show that question, so let's get that done. So if x is 1 plus 0.2 minus cos t, then dx by dt is just 0.2, and then cos differentiates to negative signs, this is plus sine t. Okay, so let's plug this into our integral formula here and see what we get. So we get the integral between 0 and pi. Y is k sine squared t, and then dx by dt is 0.2 plus sine t. That's our dx by dt, and then we've got a dt. And again, because of this here, we know this has to be equal to 1. So you can see we're kind of already on the right tracks. So where do we go next? Well, you should know that if you've got an integral, you can pull out a constant to the front of it, like so. That's step number 1. Step number 2 is to expand these brackets. So we've got 0.2 sine squared, and then for this bit, I'm just going to write them separately for now. And the reason for this is, in my final answer, nowhere do we have a sine cubed, so it would be pointless to expand. Now, again, comparing to this final answer here, I can see there's no sine squareds either, which means we must have got rid of the sine squareds. And if you know your identities, you will know this one. Sine squared t is 1 minus cos squared t. So let's go ahead and do that. But before that, just for a bit of change, we'll change the colour. So 0.2, lots of 1 minus cos squared, plus sine t, lots of 1 minus cos squared, dt, and this equals 1. Now hopefully in our next step we're going to get there. So 0.2 times 1 is 0.2, 0.2 times negative cos squared is minus 0.2 cos squared, and then we've got a plus sine t minus sine t cos squared t dt equals 1. Now is this the same? It is, but just to make sure we're going to get that third mark, let's write it exactly as they had it. So 0.2 plus sine t minus 0.2 cos squared, and then minus sine t cos squared t dt. And then I always like to finish off these show that questions excuse me, with something like this, as required. Okay, hope that makes sense. Let's move on to part B. Okay, so it doesn't get any easier in part B, to be honest, because that was just the show that question. You can actually attempt part B if you don't know how to do part A, which I suppose in some ways is quite nice. So let's see. So, determine the exact value of k. So if k times the integral equals 1, this must imply that k is 1 over the integral of 0 to pi dt. Okay, because we know they multiply to give 1, so to get k on its own, we have to divide. So I'm looking along my integral. That, by the way, means we're going to need to work out this integral. I'm looking along my integral. I know how to integrate point 2. I know how to integrate sine. The other two are a bit trickier. Let's start with this one. Sine t cos squared t. Now, with this one, hopefully your teacher or whoever's been, maybe you're learning by yourself, but what you should be looking for with these kind of questions is one part the derivative of the other? So I can see that sine is actually the derivative of cos, or rather, cos differentiates to minus sine. So this thing here actually integrates to, we've got a cos cubed, we've got a divide by 3, and then a minus. Okay? And then looking at the other one is a bit trickier. So 0.2 cos squared. Now, what you need to know for this one is that cos squared is actually the same as cos of 2t plus a half. No, sorry. Let's try that again. Kind of got caught in two minds. So it's the same as a half cos of 2t plus a half. Now, where does this come from? It comes from the double angle formula, okay? So you do need to memorize, or it is beneficial if you can memorize that cos of 2t is 2 cos squared t minus 1, because then we add 1 to both sides and divide by 2. Okay, really, really useful. Don't let that go unnoticed. All right, so then this we will be able to integrate. So I think now we're kind of ready to go ahead and give it a go. So 0 to pi of the integral to 0.2 plus sine t minus 0.2 cos squared t, and then minus sine t cos squared of t dt. So this is going to equal, in big round brackets, 0.2 goes to 0.2t, sine t goes to negative cos t. All right. This 0.2 cos squared, we know this is the same as this. All right. So we're going to have cos integrates to sine. So this is going to be, sorry, a minus. Yeah, so it's going to be a minus 0.05 sine of 2t. So what have I done there? Well, from here, 0.2 divided by 2 is 0.1. Cos integrates to sine. And then we had to divide by 2 because of the argument of the cos. And then 0.2 times a half is 0.1. So this is just going to go to minus 0.1t. You might be thinking, where does the minus come from? But that is here. Okay, and then finally, sine t cos squared goes to negative cos cubed t over 3, which is just plus cos cubed t over 3. Okay, so that's kind of the hard bit done now. Let's just double check if we differentiate, do we get back to 0.2 sine t negative 0.1 cos 2t, which is down here, and then negative 0.1, yeah, good. And then this goes to 3 minus sine t cos squared over 3. Yeah, so I think we're all good with that. Okay, now I like to set up two big round brackets, and we're going to plug in pi and we're going to plug in 0. It's good to bear in mind the graphs here as well. So 0.2 pi, cos of pi, if I draw the cos graph just in here, cos of pi is this one, which is minus 1, so that's going to be a plus 1. Sine of 2 pi, if I draw the sine graph, where should I draw it? Here. The sine graph at 2 pi is 0, so that goes to 0, minus 0.1 pi, And then cos of pi we've already seen is -1, so this is -1/3. Don't forget you can just shove all this in your calculator as well. Don't try and be like me, not using a calculator. And then from the bracket with 0, we're going to get 0. Cos of 0 is 1, so that's a -1. We're going to get sine of 0 is 0, 0, and then cos of 0 is 1 again, so that's +1/3. Okay, so what have we got overall? We've got 0.1 pi in here, and then +2/3, take away -2/3, I think. So altogether this is 0.1 pi plus 4/3. Okay, good. 0.1 pi plus 4/3. Let me just wipe that off and we'll continue. So what we've just seen is that the integral, 0 to pi of all that stuff, was 0.1 pi plus 4/3. Remember earlier I said that k was going to equal 1 divided by the integral. Okay, and we now know what the integral is. And then it's not the nicest value here. So what we can do is we can times both sides by 30. Now why 30? Well, 0.1 pi is pi over 10, and the lowest common multiple of 10 and 3 is 30. So when I do that, I get 30 over 3 pi plus 40. And this is a bit nicer now. It's still not a very nice value, but that is the answer. Really hope this helped. Keep revising. See you for the next one.